This is exploring environmental data with pandas and GeoPy using Python. I'm Ashley Jangleski, and this is for the Syracuse Women in Machine Learning and Data Science meetup group. I'm a co-organizer for this meetup group, and I am based in Syracuse. I work as a data analyst for Osmos Utility Services, Inc., and my educational background is in environmental science, so this data set is close to my heart for what I had a lot of interest in college and working afterwards in different field survey environments. And a couple years ago, I decided to pursue a data analyst nano degree through Udacity, which is a short program that helps transition people from non-traditional backgrounds to working in the data science sphere. The data that we're going to be working with today comes from the St. Lawrence Eastern Lake Ontario Partnership for Regional Invasive Species Management, also known as the SLELO PRISM. It is in a section of New York that encompasses a couple different counties and also has a large section, as mentioned in its name, that is on the eastern side of Lake Ontario. And all of these different divisions of New York are for regional management because there's different invasive species that can come into any given geographic area. So it kind of helps to have all these different parts working together instead of having just one big whole program for managing invasive species. And then the data that we're going to be looking at comes from boat launch steward surveys, also known as part of the Aquatic Inspection Survey Program. And this data set is from 2016 field season, which is pretty much the summer of 2016, and encompasses data collected at 4 different boat launches along Lake Ontario, including Cape Vincent, Sackett's Harbor, Henderson Harbor, and Wright's Landing. So then for the data specifically, it looks at a lot of different questions that people get asked as they're taking their boats out onto Lake Ontario, but specifically the invasive species portion comes in for plants and animals that can be found on people's watercrafts. And so the species that were targeted with these surveys include coontail, eelgrass, elodea, and native pondweed for native species, as well as a couple non-native species that are Eurasian water milfoil, variable leaf milfoil, and zebra mussel. Okay, so now we're going to go to the Jupyter notebook that we use for this workshop. So I have this both in a Google Colab format if you would prefer that, or a straight Jupyter notebook, but I'm going to run through the Jupyter notebook being supported on my local machine. But the benefit of having Google Colab is that you do not have to have any of the packages that we're going to be using installed on your local machine. But since I do, I'm going to use this. Okay, so as mentioned before, this is looking at this boat launch steward data set, and then we're pretty much going to be looking at this survey data set that is predominantly categorical and trying to find different ways of translating that into numeric values and have different ways to look at it for when we finally go to make visualizations for it. So I'm going to run this first code block to get our packages imported. As you can see, we have a variety of different ones that we're going to be using. As mentioned in the title, pandas is going to be a major one because we want to have our way of viewing our tabular data as we work through it so we can track changes. And then GeoPy is going to come in to help us access different geocoding web services. And for the imports for GeoPy specifically, get Nominitim, which is a free service that uses OpenStreetMaps data to find locations, so you don't need an API key to use it. And there are different alternatives for specifying with GeoPy. You can use like Bing Maps or Google Maps, but you do need an API key for accessing information through those. And then we're going to import, for calculating different distances between coordinates, we're going to import the Great Circle. That is, instead of taking on like a flat surface from point A to point B, this takes into account the curvature of the Earth into different distance calculations. We're going to bring in NumPy for number handling situations. We're going to import AST for processing some of our abstract syntax is going to be coming up in the data frame. And then Matplotlib matplotlib for plotting, and then seaborn as a wrapper for matplotlib. With pandas, we're going to specify that we want the max columns equals none because we want to be able to see everything all at once. And this last bit of code specifies Google Chrome as our user agent for GeoPy. This is just something that needs to be specified to get our geolocator to work with this package. And then we're going to import our survey data, which is just this boat launch steward data inside of our data folder. We'll run dataframe.info to get the summarization of this data set. So we've got a lot of different categories here. As you can see, the vast majority of them are coming in as objects. We do have 1,166 records, but within that, as you can see, there are some null values that are not considered. For example, for our species ID column, that because species weren't found on every single boat, would not have that full record of 1,166. But it kind of encompasses the different things that people look for. So we'll have our steward, whoever was collecting the data, which boat launch it was, weather conditions, the date, inspection time, boat type, group size, state of registration, whether boats were being launched from a boat launch or whether they were coming into the boat launch when the survey was conducted, whether or not there was prior contact with any type of boat launch steward, and then different spread prevention steps for measures that the boaters take, whether or not aquatic organisms were found, the identification of the different species that were found, if any, whether or not the boater accepted informational materials, and then a couple of different categories for where the boaters had traveled from and where they were planning on traveling to. So for the last water body visited, this would have been within 2 weeks, and a lot of the survey responses did not specify state or anything like that. So I manually went in and added that information for the cleaned categories for both the last water body and then the next water body. And the next water body category is wherever the boaters plan to travel to next after boating in Lake Ontario. And then other categories include the planned travel route for how to reach this next water body, whether or not a boater would use a decontamination station, which is pretty much a setup to clean your boat as you're about to launch into a new water body. So it would help you get rid of any debris, and then also the same idea for as you're coming back in to a boat launch that you can clean off your boat again. So you'd be reducing the spread of invasive species. And then the other categories are purpose and then notes. Here we just have a breakdown of the different types of information in each. So as you can see, as mentioned before, a lot of categorical data. So some of this we have shortened into different abbreviations. For example, boat type is just signified by a 1 or 2 letter combination. As we get into it, we're going to have a lot of different string values that we're working with that we'll be splitting up. For different categories, such as this, we have for spread prevention steps, there's a wide array of different ones that people could choose from. So that is also abbreviated. Same thing goes for the species ID instead of writing every single one out. So we had these specific ones that the boat launch stewards were trained on identifying. If they weren't able to identify something, they would put unknown. I created another category called other because for the actual raw data for this, there were a lot of that would say things such as little green worm or different just like mossy algae, mossy green thing, and things like that, that to the best of our knowledge, that doesn't qualify as, an identification, a successful identification of an organism. So we're just gonna bin that into an other category. If anything was not recorded, that would just be a null value. And the same thing goes for the rest of the data in this table, is that not recorded values were interpreted as nulls. So then we'll use pandas head function to show us what the data looks like on this tabular format. So then we'll grapple with the data, and some of it, I'm not going to cover everything here. There's going to be a lot of this that is left to You can clean it if you want to, if it's something you find of interest. For example, like the weather conditions category has a wide variance. There weren't a set number of conditions that the stewards were choosing from every single time. So that leaves a lot to be standardized in that realm. So then the first thing that we're going to do is we're going to convert our date and time columns to be actual like date and time data types. So up here in our info, we can see that both of these are listed as objects. So we're going to want to change that just as a part of our cleaning. So we'll run this first code block. So we're just going to create two variables. One of them is dates, and we're going to use pandas to date time on the date column, and then we'll just specify, this is more of just good practice if you have like a very large data set. If you do cache equals true, it'll help speed up the process a bit. And then we'll create another variable times, which is going to take our inspection time column and then create it into a time delta. And then we will also give it another argument, which is errors, and then we'll specify coerce, because this will take any of our none or not recorded values and just skip that as it's processing through the times. Otherwise, it would throw back an error and we wouldn't be able to convert these all into times at once. For these columns, I'm not going to create new ones. I'm just going to rename the ones that are currently there with our new variables. We'll run dataframe.info again to double check that these have been changed and they look good. Do dataframe.head again, and then the next part that we're going to do is to take our spread prevention steps and our species ID and extend them. So for both of these, you can kind of tell with this first record, they're comma delimited for if there are multiples in each of them, and we're going to want to create multiple columns for each of the options. So we're going to create two different data frames to do this that eventually we're going to merge back into one, but this is more to keep things separate as we're running through this to make sure everything runs okay. So we're going to create one data frame and we're going to use pandas concatenate function, and we're going to bring in the original data frame and then another set, which will be from that data frame. We're going to specify our spread prevention steps and then convert that column into strings, and then use pandas get dummy function and separate based on a comma. And then we'll rename that to be prevention step underscore, and then whatever the step itself is, which is specified by X. We'll run that, and then we're going to do something similar for species. We will just do a function just to preview the species ID output for this data frame. The pandas get dummies function is used a lot for like machine learning and things like that, for getting encoding for what your variables are. So as you can see, instead of having, we just had our one species ID column over here, we now have one column for each of the given species that were found during the surveys. And then the next step, we're going to split on the last water body cleaned column on its delimiter, which is a little bit different because we use commas in that column to also specify the state name, which is going to be very helpful once we go to geocode this data. So then both of the last water body cleaned and the next water body cleaned columns have the same delimiter. So we're going to split them both in the same manner. So this function is going to create another data frame and run with it from the last water body cleaned column. We're going to split based on that delimiter, and then n equals 0 function. I think that's specifying, to look up what that one was, but we'll do expand equals true. And then for this data frame, for these columns specifically, we're going to apply this beginning of previous location and then just these brackets to enumerate for each one that comes out of it. And then the format, as mentioned before, for the enumeration will be +1 for each, and then for the total number of columns. So then our output from that will be, instead of having just that one previous location, we're going to have, because the maximum number of responses that were given to us was 5, we're going to have 5 new columns from this. And because not everybody gave 5 previous locations, we're going to have none values for the ones in between. And so we'll do the same thing for the next water body cleaned. And so the max number of responses for this, for any given like single boater survey, was 3. So we only have 3 columns for this. Okay, so then what we're going to do is we're going to take all of the locations mentioned in the data frames that we just created. We're going to geocode that. And so instead of running through all the data frames and running on every single instance of all of these locations that many of them repeat, we're going to create a flattened array for them of all of the unique locations. What we're going to do is take all of the locations previously, we're going to use this function, which is pandas unique, to get all of these values, and then we're going to specify rabble k, which actually flattens the argument for both of these. And then after we do that, we're going to take both of those locations and we're going to iterate through them and create a single array of all of these values. So then, just to show, this is going to be a lot, but we'll print both locations. So this is taking everything. And as you can see, we're going to have a couple of values in here. So we've got none if people weren't traveling, like they hadn't come from another water body before, this was like their first time boating within that like 2-week window, they could have specified none. And then we have obviously like our null values as well. And so from the array above, we're going to remove some of those. And then another one that I didn't highlight is undecided. So sometimes a boater would give an answer like, hey, I am not actually sure of where I'm going to go to next. And so we would just categorize it as that. We'll make a dictionary from all the locations. And with that, we're going to append the coordinates that we're going to grab using GeoPy. So we create a dictionary and then we zip together all of these clean locations, and then we make a pandas series of these and apply our geolocator.geocode from GeoPy. And then on top of that, we're going to apply our function to get both the latitude and longitude from each. And so we need to specify before we run this that for the latitude, if the value given does not equal none, it can run. Otherwise, it stays none. And so we specify that for both latitude and longitude. Otherwise, the function would trip up once it hits that first value that it can't produce a coordinate for. And so this process actually, it takes about 2 minutes for this to run. So in the meantime, I'm just going to go over some of the caveats that come with GeoPy. So this is definitely a way that we're going to use to create different variables for us to grapple with, but in no way is it going to be, the exact location that people came from before. So go back to this, go back to present. So while that's running, this screenshot comes to us from GeoPy's documentation. So it's showing that GeoPy isn't necessarily doing anything outside of working with existing geocoders. So it's providing a way for us to take these different geocoders on the web and use them to produce the coordinates that we want to get. And as mentioned earlier, there are different platforms that you can use if you want to specify these different geocoders, but we're going to use, as mentioned before, this OpenStreetMap one because that's like free data and we don't need to specify any API keys for it. So it's kind of a user-friendly thing for going over in like a workshop fashion. And then the other consideration, as mentioned before, is that the distances that are being produced by the geocoder. So when somebody says Lake Ontario or the St. Lawrence River as the last place that they brought their boat, this is an example of the kind of information we're going to get. So although our boat launches are along this like side of eastern Lake Ontario, to the geocoder, taking a very large water body like this, it's going to give us a point in the middle of it. And so that's just something that just needs to be thought of, like, as you're working with it. You can make the decision to set it for, somewhere over here and determine that is Lake Ontario for the data that you're using. That's fine. But this takes into account, like, okay, it could be in like any of these places. And then the same thing for the St. Lawrence River. Although a lot of the boaters that these surveyors were coming across were coming from maybe this small, like, western end of the St. Lawrence River, the value that comes in from OpenStreetMaps is going to be all the way up here at the top. And so that'll come into effect when we get into our different categories of calculating distance. So a distance from up here is going to be vastly farther from where the boater might have actually come from before. So then we'll see. So that's all done loading. And then what we're going to do is we're going to take the dictionary that we just created and we're going to map it to each of our previous location columns, but we're going to create a new one called with underscore coordinate for the total number of these. Okay. Now we'll do the same thing for the next coordinates. Okay, so then we're going to save each location data frame as string types for later use. So this is important if you save at any given point the data frame like between this point and that point, because what's going to happen is if you save it, that output, unless you specify otherwise, our coordinate columns are going to come out as objects, but we want them as strings because we're actually going to parse them for the geocoder. So then another column that we're going to create, which will help us with visualizations later, will be to specify the boat launch coordinates for each of the 4 boat launches that were a part of this survey data set. And so it's just a small little dictionary for those, which is just the boat launch and then the XY coordinates for that. And so then we'll just create a variable of these mapped coordinates to the boat launch column, because what we're going to want to do is insert this column at a certain place within our data frame instead of at the very end. So this pandas insert function is going to allow us to specify, we'll run this code below, that we want at index 2, we want our boat launch coordinates placed. And so that's helpful if you're, manipulating data and you realize, hey, I want to have this column at a certain location in the data frame. Like, that's a great function to be able to use to have it, visualize the way you want it. Okay, so then what we're going to do is take our data frames that we created for our different locations that boaters had traveled to or were planning on traveling to and join them into one main data frame. So the first step will be taking the previous locations and merging them with our original data frame and then adding in the new ones that we just got. We end up with this data frame 7. So I understand you guys can name it like different. You'd rather have it be whatever named variables for each of the data frames. I've just done it this DF and then whatever number it is, just for ease of use throughout the notebook. So then we end up with this very large data frame, but it has all of our different variables, including the ones that created, including these coordinate columns that align with, for example, so like for Lake Ontario, it'll say whatever the next coordinate is over here in this column, which aligns with that. So then get to the point where if you want to save the CSV for the data frame that we just made for later use, like you can do that if you don't want to run the geocoder next time you're working with the data. The only thing I would keep in mind is if If you do that, then you will lose unless specified otherwise some of the different data types that we've indicated, including the date time ones. But so I'm just going to leave that as it is, just as a comment. So that's there if anyone wants to save it at that point. So then what we're going to do is we're going to create some new rows for the distances between the specific boat launch that the survey was taken and then the ones where the boaters had either come from or where they were going to go next. And then for this, as mentioned before, there are multiple columns for all of the next and the previous coordinates, but I'm going to work specifically with just whatever was specified in the first column for each. And that's going to also encompass the highest number of responses because the original intention with the surveys was to get just, one water body that the boaters were going to visit either next or that they had visited previously, instead of getting, all these different locations all at once. So it'll just choose one of those, but you can definitely go through the data and run through it, figure out maybe which one was farthest or closest to begin with, and work with that as you would like. So for this, what we're going to do is create a function for the first distance calculation, and we're going to specify that we want to bring in the row for the previous coordinate 1 and then align that with the boat launch coordinates that are in that same row. And then for the function itself, we're going to use from GeoPy, we're going to specify that great circle distance and then bring in our AST package, which will handle some of that abstract syntax of the latitude and longitude. So it is provided in the data frame. We do have our parentheses and our commas, but this will make it so we don't have to go through and weed that stuff out for this code to be able to run. With that, we'll specify the literal evaluation for coordinate A and then coordinate B, which, as mentioned before, that'll just spit out that solid number value that we want to use for each of the latitude and longitude. And then the last part of this argument is what you would like your measurements to be in, and we're going to do it in miles. Another part of this, we need to specify that once a value error comes up, just return none. And this will help us, once again, run this code without errors because there were a lot of instances of people, not responding or having responses that wouldn't fit the bill of being able to use the geocoder on for when looking for distance values. We will use this function to create a new column in our data frame. And so we're going to do the same type of thing with the coordinates of the water body the boaters plan to visit next. From that, just as a little bit of a test to make sure that our distance traveled previously worked correctly, we're going to look at the unique values for it. And if it doesn't work correctly, you'll get just maybe one value or something here. But we've got all these numeric values, so we know that at least that part of it ran correctly. As mentioned before, if you want to do additional cleaning for, where the coordinates are actually plopping down for each specific large water body that people had indicated, then you can obviously do that as well. And then we're going to look at our info for our data frame that we're working with at this point. And just take a look at it. I know there's definitely a lot more columns than when we started, but this will give us a lot more an opportunity to work with the data than we had originally. From these distances that we just created, another variable that we're going to create and add into our data frame is quantiles for each. So for example, for the distance miles next, we'll look at the describe function from pandas and look at the different summary statistics for it. So we can see we have all these different counts of variables that were there, and then the mean distance in miles is about 125 miles, pretty large standard deviation for that as well. And then we have these min and max values too. So obviously about over like 5,000 miles is gigantic, and we are going to work with this data, but we're going to take a look at simple value counts for each. So then what we're going to want to do is to use pandas qcut function, which is going to take all of these different values and cut them in a way that makes them equal, but takes into account for each of these different unique values, how many times they occur within the data set. Okay, so then once we get to this point, we're going to create two new columns for the quantiles for each of the distance variables that we created. And then we're going to use pandas QCut, specify our column that this is going to be working on. We're going to use 4 quantiles, so that's what this Q signifies. And then for the duplicates, we're going to say drop. If pandas splits the data evenly into 4 different groups, but it finds that because of the number of counts, that 2 of the counts are duplicated between the quantile divisions, this drop function will make it so that we don't have those duplicates. And then we're going to do value counts for quantiles, and we can see how it was split up. So it tries to go, as evenly as possible for the distribution of how many are in each set. You can see we've got a lot on this lower range, and then we've got for our last and our fourth quantile anywhere between about 80 miles to over 5,000 miles. We're going to create some visualizations based on this data that we've created, and we're going to work a lot with the count plots in Seaborn just to give an idea of, the different directions that you can take for working with survey data in general before we bring in some of the variables we created. So this first one, this is kind of the same format for a lot of these for the actual code for it. We're specifying our figure dimensions and then using Seaborn, what kind of plot we're using. So we'll say count plot, and then we specify our X values, that is the data that's being counted, along with the data frame itself. And then I just have some formatting things in here, such as the edge color and then the palette for the graphs being created. And then just some stuff to clean up, such as taking the X label out of it because, we have this title up here, which is summarizing what the different variables are. And then plot.show to actually show us the graph. So we'll do the same thing. The first one was whether or not boaters would use a decontamination station. The second graph is going to take in that same variable, but we're going to throw in a hue of boat launch to show us at which boat launch what some of the different responses happen to be. We're going to do one using our quantiles that we just created for the distance traveled previously. And so this shows us, and granted, for each of these variables, you can do some very basic plotting to show for each of the variables themselves of what the data looks like just for that one thing. So for example, the survey data for whether or not somebody would use a decontamination station, the vast majority of people said yes in the surveys to begin with. So that's why it's not super surprising that we look at this data and for each single quantile, it has pretty much the same shape as it would if we had graphed just this alone. But it's cool to come in and bring in our different variables to see, maybe, so for example, from this category, like the people that had said yes, that were traveling between 50 and 61 miles. And as mentioned before, relative values, because, we do have this tendency for potential error with where our coordinates are actually spitting out. And so the next kind of graph that we're going to make is a box plot using Seaborn. And what we're going to want to do, because we're looking at our distance traveled again, we're going to use an argument that Seaborn has, which is show flyers, which is where we are able to specify if we want to include or exclude outliers. So I'm going to run this with true to just show what it would come out as if we had that set as true. So as you can see, because we have such a huge range of different distances people traveled, we can tell like the boxes are way down here and we want to be able to see what they're trying to communicate. But If we specify false, and we get graphs like this where, yes, it does not have every single value plotted on it for the people that were traveling from Texas, from the boaters that were surveyed, but this shows us for the people that were in this certain range of miles of these boat launches what the data can look like. And so this is taking the purpose of the boating trip and then taking into account their previous travel distance. So you can see for people that are boating recreationally, they have maybe the greatest range based on this of miles traveled, but for fishing and for both fishing and recreation for this instance, this seems a lot more predictable than something like this with such a large variation. And so now we're going to plot the same type of thing, but we're going to look at the purpose of the boating trip and then the distance to travel to the next area. So then this is a lot different than this first graph that we have. So people that were traveling for both fishing and recreation gave prospective locations that were, from this, the highest of responses given. And then fishing tends to stay more locally, and then recreation is a little more variable as well. So then the last thing that I'm going to go over is to kind of leverage what pandas has for specifying specific parts of your data frame for what you want to work with. So there are endless possibilities for going through different queries and looking at all of these different ways that people responded. But what we're going to do is we're going to take the category for whether or not aquatic organisms were found on the watercraft, and we're going to create a new data frame for that for the purpose of graphing. So we're going to do that using the specifying the location of, for this specific column, responses equal to yes. And that's important because if I had graphed just based on both responses for that, I would have the vast majority of people, if I was looking specifically at species, which is what we're going to do next, it wouldn't even be applicable for them. So it's kind of reducing the amount of noise for something like that. For this last graph, we're just going to take a bunch of different subplots for different invasive species found and plot them together to see, based on the same scale, like what was found most frequently. So this takes into account total observations of invasive species. I think we'll take that out. We'll do observations of invasive species because curly-leaf pondweed is also an invasive species, but we've got for Eurasian water milfoil, so that for the responses of people where 1 means that yes, it was found on the boat, out of all of the people that had species found, that was found most frequently for the count compared to variable leaf milfoil and zebra mussel. But it's just nice to be able to visualize all of these in the same manner and work with them in a way that shows, like, from the different encoding that we did earlier, shows them side by side, because ultimately that's what we wanted to accomplish with splitting things up like that. And then for more investigations with this, there's, if I go back up to the top, there's a lot of different categories that this came with out of the box, such as, whether people were launching or retrieving their boat from the boat launch, so you can work with that to create more visualizations. And then I didn't even scratch the surface with the spread prevention steps that people take. And there's a lot of opportunity for creating more columns for binary values to say, like, well, for all of the spread prevention steps, some people said none for all of them. So to have like a yes or no column for whether or not any steps were specified, and working with that to graph the data. But ultimately, as mentioned before, there's a lot of possibilities with it, but to be able to grapple with it and to use both pandas and GeoPy to kind of give us an idea of what we can create with visualizations. There's a lot to work with there. And then another, obviously, opportunity is to take the coordinates that we have and then graphing those using different things like using Mapbox for OpenStreetMap. But that kind of goes back to using API keys for the actual code that you're running. And just for the sake of this being a tutorial, I didn't really want to run anything where I would have to specify that kind of sensitive information within the code that everybody's sharing. But with that, happy coding, and I hope this was a helpful investigation of the possibilities of using Python for both pandas and GeoPy. If you have a data set that does have location values that you're looking to investigate a little bit more.